Good afternoon to KGBV students. This is Vani from KGBV KAVALI, Nellore district. We already discussed about the previous class in real numbers, 3 parts. Okay. First chapter, real numbers in 10th class. Next, we discuss about the second topic, second chapter, sets. Second chapter is sets. Okay. This is very important and easy chapter. So, sets is 4 exercise in this chapter. We learn to 4 exercises. First, what we learn in the sets, new terms in the set chapter. Okay, this is the mind map. What we learn first to sets chapter. This main topics is mind map. First one is definition of set. What is set? We learn about the what is set. Okay. Next, second topic, roster and builder forms of sets. We represent the sets in 2 types of forms. First one is roster form. Second one is builder form of sets. Okay. Next, we learn the universal set and subset. Universal set and subset. Next, we learned the Venn diagrams. Venn diagram. How many Venn diagrams? Which type of the Venn diagram is important? Next, basic operation on sets. Basic operation on sets. Operation means intersection, union, minus. This is the operations. Operation of sets. Next, symbols. Symbols means we pronounce the intersection, union, subset, belongs. This is the symbols of set chapter. Okay. Next, cardinality of finite set. Coordinate of finite set. Okay. Next to types of sets. Next to types of sets. We learn about the types of sets. Students, it is the mind map of set. Very important. These 2 topics cover the exercise 1. Exercise 1. Okay. These 2 topics. What is the set and form of roster and builder form of sets. These 2 topics is cover the exercise 2.1. Next, second exercise cover the type of sets. Type of sets means finite sets, infinite sets, universal sets. Next, empty sets. This types is types of sets. We cover the exercise 2.2. Okay, second exercise we cover this topic. Next, we cover the basics operation of set is exercise 2.3 and Venn diagrams. These 2 topics is cover the exercise 2.3. Okay, in our textbook. Next, last exercise 2.4 is cover the coordinate of finite set. Coordinate of finite set. Okay. First, we discuss about the what is set. Okay. Students, first definition of set. Definition of set and examples. Next, a represent of sets. Represent of sets. 2 types, roster form and builder form. Roster form and builder form. Next, type of sets. Types of sets. First one, empty set or null set. Empty set or null set. Next to universal set. Universal set. Next to subset. Subset and supersets. Subset and supersets. Next to equal sets. Equal sets and equivalent set. Equivalent set. Next, finite set and infinite set. This is the many types of sets. With the examples, we discuss about the examples. Okay. Next, basic operation on set. Operations. This 3 is basic operations of set. Union of set. Second one is intersection of set. Third one is difference of sets. Union of sets means this symbol. This symbol is union of set. This symbol is intersection of set. Difference means minus symbol. Difference means minus symbol. Next, Venn diagram. Venn diagram. We draw the different types of Venn diagrams. Next, coordinate of finite set. So, types of sets lo finite and infinite sets. We find out the coordinate in finite set. This is the structure of sets. Sets topic structure. We learn about the sets chapter. This types questions is problems. We use the
Let's have a look at these images. What do you think about them? We have a bunch of keys, a school of fish, a group of letters, a pile of books, and a bunch of flowers. The one thing that can be seen in common is that everything is in the form of a group or set. And well, that's our topic for today. Sets. But what exactly is a set? A set can be formed of anything that can be well defined or distinct. Now, let's see what do we mean by well defined or distinct. Let's take an example. A set of numbers from 1 to 10. Now, this is well defined. You can list all these numbers also, right? So, this can be a set. Let's consider another example. A set of smart students or a set of generous people. Can this be considered as a set? No, not exactly, right? Because here, smart or generous cannot be defined or measured, or we can say that these are relative terms because the meaning of these words will change from individual to individual. Hence, we cannot make a set of these situations. Let's take a simpler example. A set of all the letters that comes after T. So what all letters will be there? U, V, W, X, Y, and Z. Yes, so this can be also called as a set, right? Let's see a few of these examples if we can form a set of them or not. The first is states of India. So, can we form a set of this? Yes, because there are 29 states in India and you can list all of them. The second one is strong students in a class. Well, this cannot be a set because strong is a relative term. But suppose here if I'll add a condition like students who weigh more than 50 kg in a class are to be considered as strong. Can now this be formed a set? Yes, because now we have a number, a quantity, or a well-defined and distinct property that we can use and form this set. Right? Let's see the next one. Students who have scored 70% and above in the last semester? Yes, you can form a set of this. Collection of great people in the world. Again, great is a relative term and we cannot form a set of this. So I hope by now you know what are sets and in which conditions we can form a set and cannot form a set. Let's move to the next step. So how do we present these sets? There are two different ways to write these sets. One is listing method or also known as roster method. The second is rule method or known as set builder method. Let's see what listing or roster method is. If I want a set of all letters in the word mathematics, then how will I write it? Well, this is a very simple method. Let's look at this in a little more detail. All the letters in the brace or curly brackets are known as elements. A or any letter can be used to represent this set. However, there's one tiny mistake that is there in this set. The elements in this set are never repeated. Every element appears just once in a set. Hence, the solution of this set of all the letters in the word mathematics will be A is equal to curly brackets M A T H E I C S, curly brackets closed. This is how we present a set in a roster method or a listing method. Now, since just we have listed all the letters is the reason why it is known as a listing method. Next can be a set of all the days in a week, a set of all the rainbow colors, etc. We have also been studying sets in few of our previous grades. It's just that we never knew that they are sets, like a set of natural numbers, a set of whole numbers, a set of integers, etc. Sets are used in a variety of places in mathematics, but we'll see that in the future sessions. So now I believe you can make any set using the listing method. Now what happens if I ask you to form a set of all the whole numbers between 0 to 10,000? Can we use this listing or roster method to list all these whole numbers till 10,000? No, right? Hence, we have this rule method or set builder method. Now, since we are building a particular set, instead of writing all the elements in the set, this is known as a set builder method. Now, a set using set builder method is written like this and is read as A is a set of all x such that x belongs to whole numbers and x is a whole number between 0 to 10,000. Now, was this a little difficult? Let's try another set. Now, can we represent the set of all letters in a word mathematics in the form of a set builder form? Well, yes. Let's name this set as B. B is a set of all x such that x is the letter of the word mathematics. Every set can be represented in the set builder form. Try a few of these sets in the form of listing as well as set builder method. Now, why this method is known as a rule method? Now, here we can see that we have added certain conditions in this set. This is the reason why this is also known as a rule method. So till now we have seen that what is a set, things that can form a set, and ways to represent these sets. In our coming sessions, we will see
empty set, singleton set, finite set, infinite set, equal sets, equivalent sets, universal set, subset, proper subset, superset, proper superset, power set. Empty set, a set with no element. This is the symbol of an empty set. Let's name it set E. Another way of writing set E is using the symbol, the null set. The cardinality of set E is equal to 0. This notation simply means the number of elements. Singleton set, a set with one element. Set S is a singleton set. The cardinality of set S is 1. Finite set, a set with limited elements. Example, set F is the set of counting numbers less than 6. The elements of set F are 1, 2, 3, 4, 5. The cardinality of set F is 5. Infinite set, a set with unlimited elements. Example, set N is the set of counting numbers. The elements of set N are 1, 2, 3, and so on. The cardinality of set N is infinite. Equal sets. Two sets are equal if they have the same elements. Example: set E is a set of letters in the word earth. The elements of set E are EARTH. Set H is a set of letters in the word heart. The elements of set H are HEART. Set E and set H have the same elements. They are equal sets. Set E equals set H. Equivalent sets. Equivalent sets have different elements but have the same number of elements. Example: given set F and set H. The cardinality of set F is 5 and the cardinality of set H is 5. The two sets have different elements, but they have the same number of elements. Set F is equivalent to set H. Universal set. Universal set is the set containing all elements and of which all other sets are subsets. The universal set is represented by a capital letter U. Example: let U be the universal set. Set U is the set of all vowels in the English alphabet. All other sets are subsets of the universal set. Set A is a proper subset of set U. Set B is also a proper subset of set U. All the elements of sets A and B are also found in the universal set. Another example: set U is a set of counting numbers. Sets A, B, and C are proper subsets of set U because a universal set contains all the elements in a particular problem. Subset. Set A is a subset of set B if and only if every element in A is also an element in B. Here's an example. List all the possible subsets of set A. Number 1, a set with 3 elements. 2, 3, 4, sets with 1 element. 5, 6, 7, sets with 2 elements. And number 8 is an empty set. How many subsets does set A have? To find the number of subsets, use this formula, 2 to the power of n, where n is the number of elements. The cardinality of set A is 3, so 2 to the power of 3 is just 2 times 2 times 2 equals 8. Proper subset. Set A is a proper subset of set B if there is at least one element in B not contained in A. In symbol, set A is a proper subset of set B. Example: given sets A, B, C, and D. Set B is a proper subset of set A. Set C is a proper subset of set A. Set D is a proper subset of set A. List all the proper subsets of set A. Sets 1, 2, 3 have 2 elements. Sets 4, 5, 6 have 1 element. And number 7 is an empty set. The set itself is not a proper subset of set A. How many proper subsets does set A have? Since the set itself is not a proper subset, the formula is 2 to the power of n minus 1, where n is the number of elements. The cardinality of set A is 3. Using the formula, 2 to the power of 3 minus 1 equals 8 minus 1 is 7. Superset. Superset is a set containing all of the elements of another set. Symbol, set A is a superset of set B. This is just a reverse of subset. Proper superset. Set A is a proper superset of set B if set A is a superset of set B and set A is not equal to set B. In symbol, set A is a proper superset of set B. Given set A and set B, while set B is a proper subset of set A is a proper superset of set B. Power set. The set of all the subsets of a set. What is the power set of set S? P of S contains all the subsets of set S. How many elements does the power set of set S have? Since a power set contains all the subsets of a given set, it follows the formula 2 to the power of n, where n is the number of elements. So the number of elements of P of S is 2 to the power of 3, which is equal to 8.
Basic operations on sets. Okay, so we have some basic operations on numbers. Let us discuss that. Very simple topic. What is 4 plus 2? That is equal to 6. Addition of two numbers is again a number. What is 4 minus 2? 2. What is 4 into 2? 4 2's 8. What is 4 divided by 2? That is equal to 2. When we add, subtract, multiply and divide two numbers, we are getting another number. In similar way, we apply some operations on sets. We denote sets with capital letters. And we apply operation on these two sets. Again, we get a set. So those are the operations. And the basic operations on sets we are having are union, intersection, and difference of two sets. Let me write that. Union of two sets. Union of two sets. It is denoted with cup symbol. Next, intersection of two sets. Intersection of two sets. Inverted union. Third one, difference of sets. Difference of sets. So we denote difference by minus. So let us first move to union of two sets. Union of two sets. Union of two sets. Yesterday we discussed what is the union of two sets. Suppose if we have A is equal to sum 2, 5, 7, 9, 11, 13. B is equal to set containing 5, 9, 11, 17, 20. Then A union B. What we have to write A union B? The elements of A or B or both. So yesterday what we did, in the previous class what we did, we wrote all the elements of A and B. If they are repeated, we cancel once. So now I'm writing directly 2, 5, 7, 9, 11, 13. Here we have 5. We already wrote this. 9, we already wrote this. 11, we already wrote this. 17, not there. We have not written, so I'm writing. So 20. So we covered all the elements of A, B. So this is about A union B. So how we defined A union B? So what is the letter which refers union? Or? Or is the letter that refers union. So let us define a union of two sets. Definition of union of two sets. Definition. It is denoted by U, union of two sets. The union of two sets A and B is the set of elements which are in A or B or in both It is denoted by A. What is the symbol for this? Cup symbol or U symbol, and it is read as A union B. A union B. That's all. So this is about union. And we solved some problems later. First, we discussed all the operations on sets. So let us move to intersection of sets. Intersection of sets. Intersection of two sets. So what is its symbol? Wait a minute. I want to erase this. No, it's not possible. Okay. Intersection symbol. Intersection of two sets. So how we define intersection of two sets? Both. Let us explain that with an example. Let us take an example. Let A is equal to 1, 2, 3, 5, 7, 9, 11. B is equal to set containing 2, 5, 7, 9, 11, 13, 14. Now, we define A intersection B as set containing both the elements of A and B. That means it should be in A as well as in B. Whether one is there in A and B? No. 2? Yes, write down here. 3? No. 5? Yes. You will write in A intersection B. 7? Yes, we have 7 in both A and B. What about 9? Yes, we have. Next, what about 11? No, that's all. So what is A intersection B? It contains elements of both A and B. So how we define A intersection B now? Intersection of sets. Let us define intersection of sets. Intersection of sets. What is its symbol? This one. The intersection of two sets A and B, is the set of elements which are in both A and B. Next, we have to write the notation. How we denote it? It is denoted as A intersection B and is read as A intersection. Spell that symbol as intersection B. A intersection B. That's all. Now, let us discuss the set builder form of both union and intersection. So what will be A union B? X such that X is in A or X is in B. We use the letter OR for union. Next, let us write the set builder form of A intersection B. A intersection B equal to X such that X belongs to A and X belongs to B. We use the letter AND. For A intersection B. Use the letter AND for A intersection B. This is about A union B and A intersection B. We will discuss a difference of a set and let us move to some problems related to union, intersection and difference from your textbook. So what is difference? Difference of two sets. Let me take another board. Difference. Change the pen. Difference of sets. How we denote it? We denote that with minus. Suppose if we have A is equal to 1, 2, 3, 4, 5, 6 and B is equal to 3, 6, 9, 12. Then A minus B will be the elements in A but not in B. A minus B means, let us write all the elements of A. 1, 2, 3, 4, 5, 6. It should not be in B. Whether 1 is in B? No. So it will be here only. Whether 2 is in B? No. It will be in A minus B. Whether 3 is in B? Yes. Here 3 is there. Here 3 is there. So what we will do is write it out. Next, what about 4? No, 4 is not in B. So we keep in A minus B. What about 5? 5 is also not in B. So we keep that. What about 6? 6 is in B. So we should not take that. So what will be A minus B? A minus B is equal to 1, 2, 4, 5. the elements of A that not are in B. Similarly, what is B minus A? Let us check that. B minus A. So since we have B minus A here, let us write first B. What is B? 3, 6, 9, 12. But these elements should not be in A. Whether 3 is in A? Yes. So we strike it out. Whether 6 is in A? Yes. We strike it out. Whether 9 is in A? No. Whether 12 is in A? No. So then what will be B minus A? B minus A is equal to 9 comma 12. So how we are defining difference of two sets? Let us define difference of two sets. Difference of two sets. Difference of two sets. Let A and B are two sets. Then A minus B is defined as elements of A but not in B. Elements which are in A but not in B. We define difference of two sets as difference set of sets A and B as the set of elements which belong to B, which belong to A. First manam A rasam kada, belong to A but not in B. Next we have to write the notation. So we denote difference of A and B by A minus B and read as A minus B. A minus B. Clear? So how we write that in set Builder form? A minus B is equal to A minus B is equal to, how we write in set Builder form? X. Always we have to write element first X such that X belongs to A and X does not belong to B. X belongs to A and X does not belong to B. So we have discussed three operations. Let me write all those three operations clearly in the tabular form. So serial number, let me take a tabular form, serial number. So how many we are having? We are having three. First one, name of that operation. First, let us take union. Start with union. Operation union. How we denote it? We denote that as A union B. How we define it? We write it in set Builder form. A union B is equal to X such that, which word we use for that? X belongs to A. Which word we use? Let me change the pen. Or X belongs to B. X belongs to B. Or X belongs to B. Second one, what is the second one? Intersection. How we denote it? A intersection B. How we define it? A intersection B is equal to X such that X belongs to A and X belongs to B. So common, we write elements of both A and B. That is common elements in A intersection B. Let us move to the third one. What is that? Difference. Difference. A minus B. How we define it? A minus B is equal to X such that X belongs to A and X does not belong to B. We have to write only the elements of A which are in A but not in B. That is A minus B.
The sets is introduced by George Cantor, a famous mathematician. George Cantor. He is a German mathematician who introduced sets. His name is George Cantor. He born in 1845, March 3rd, and died on January 6th, 1918. And he belongs to Germany, and he worked more in the fields of mathematics, especially set theory. He introduced the set theory. Now,
next we discuss about the Venn diagrams. How many types of Venn diagrams? This is 10 types of Venn diagrams in our 10th class textbook. Okay. We expect the public examination. This type of question is very important. First one, A union B. A union B means set A elements and set B elements both are included. The whole set is called A union B. Okay. Next to A intersection B. A intersection B means set A elements, set B elements. We choose the common elements. Okay. Common elements is A intersection B. Next, A minus B. A minus B means set A elements, set B elements. We both the common the elements is subtracted. Remaining elements is A minus B. B minus A. We choose the set B elements in subtracted the common of A elements is called B minus A. Okay, diagram is this is. Next, A subset B means B elements, every B element and also A element. Okay, every B element and also A element is called A subset B. Next, B subset A. B subset A means every element of A and also element of B is called B subset A. This is the types of Venn diagrams. We write the public examination in Venn diagrams types and also problematic Venn diagrams ask the public examination. Students, this is a very important topic and we draw the A union B, A intersection B, A minus B, B minus A subset B, B subset A. We learn to do this type of Venn diagrams.
Consider a set A with 1, 2 and 3 as its elements. How many elements does this set have? What is the number of elements in this set? You can count the number of elements in the set as 3. Here's another set B with 3, 4, 5 and 1 as its elements. What is the number of elements in this set? This set has 4 elements, 3, 4, 5 and 1. The phrase number of elements of a set is given a special name. It's called the cardinal number. And there's a better way to represent the number of elements of a set. This entire thing can be written as n of A equals 3. This is read as the number of elements in set A equals 3. And this can be written as n of B equals 4. The numbers 3 and 4 are the cardinal numbers of sets A and B. The word cardinality in mathematics means size. We could say that cardinality of set A is less than the cardinality of set B.
Next, students, homework or assignment. Okay, first question is definition of set with example. Definition of set with example. Second one is define the types of sets. Define the types of sets. Third one is draw the Venn diagrams with examples. Draw the Venn diagram with examples. This is the 3 questions in yourself. Okay, write the 3 questions in yourself.